So one crucial property and the reason why we rearrange the whole thing is because the adjacent terms in the min term differ exactly by 1 bit position. So if you go and look at any two cells which are adjacent to each other, so you go and look at this cell and this cell, this cell corresponds to wxyz being 0001, this cell corresponds to wxyz being 0101. So if I take these two positions 0001 and 0101, it differs only in the value of x. W, y and z are all the same. If I take, let us say, these two cells, right, this corresponds to the min term M1001 or M9, and this corresponds to the term 1011 or M11. So M9 and M11, if you go and think about it, they differ in exactly 1 bit position, namely the third bit. So y is the only term that differs from this bit to this bit. In this place y is 0, in this column y is 1. Now if I go and look at this table here, this is wxyz is given as a sigma of 0, 2, 3, 4 up to 11. Let us see how this can be filled up. So this is a canonical sum of product. If you want to fill it up, this is 0, 1, 2, 3, right. So 0, 2, 3 and they are on. Then the next row is for 4, 5, 6 and 7. Right. So among 4, 5, 6, 7 only 4 and 6 are on. So let us do this once more. 4, we can see that 4 is here, so we put a 1. 5 is this term, but 5 is missing. 6 is the last column, and then 7 you come back. So you go from left to right, then skip, then come back. Right. So let us do it for this row. So this is for 1000, that is 8, 9, skip, come back. So 8, 9, 10 and 11, and this row would be 12, 13, 14 and 15. We can see that none of 12, 13, 14, 15 are there. So all those cells are 0, and among 8, 9, 10, 11 we see 8, 10 and 11. So 8, 10, 11 are 1, 9 is 0 and so on. One thing you can notice is even among the rows we have 0, 0, 0, 1, 1, 1 and 1, 0. The reason why we have this is because we want the same thing. We want the same thing, that the adjacent cells should differ exactly in 1 bit position. If I go and look at this cell and this cell, only W is changing, X, Y and Z retain the same values. So this whole thing is interesting because we can then do what is called combining. So these two cells differ in exactly 1 position, so are these two cells and so on. So the other interesting thing is this cell and this cell also differs only by 1 position. Even though technically they are not adjacent to each other in the picture, what you can see is this term is corresponding to 0, 0, 0, 0, this corresponds to the term 0, 0, 1, 0. So the leftmost cell and the rightmost cell here are actually adjacent of each other because they differ in only 1 bit position. So one way to think about this is you take a paper like this, right? If you put up entries here, right? So you know the adjacency right away. If you write it in the order 0, 0, 0, 1, 1, 1, 1, 0 and so on, you know what adjacency is. What else is adjacent is if you are able to roll the paper like this, right? So what I did is I had a table like this. If I roll a paper like this, whatever cells are adjacent, we call them adjacent also. Or I have a table like this and I roll a paper like this, right? One row folding into another, whatever cells are adjacent, they are adjacent in K-map sense. So what we have is this row is adjacent to this row and this column is adjacent to this column, right? And otherwise graphically whatever is adjacent is also adjacent. So this is an interesting property of K-map. This is possible only if you write it in this order 0, 0, 0, 1, 1, 1 and 1, 0, not if you write it as 0, 0, 0, 1, 1, 0 and 1, 1. So these are showing other things which are adjacent of each other. So the purple one and the green ones are also showing adjacencies. So the reason why this is interesting is if you take two min terms that are adjacent and if you combine them, the product term simplifies by one less variable. So I will explain what that means. So let us take adjacent terms now. Let us take this column, right. Let us take this column. Graphically we can see that these are adjacent to each other, right. This is adjacent to this. Now let us go and write the expression corresponding to this. What is the expression for this? This is A bar, B bar, C bar, and the expression corresponding to this min term is A, B bar, C bar. So these are product terms. The expression which captures these two ones is A bar, B bar, C bar plus A, B bar, C bar. You can see that B bar, C bar is common, so it's A bar plus A, which is same as B bar, C bar. If I take two ones that are adjacent to each other and if I combine them, it knocks out one of the variables. In this case, we know that BC is constant. We are not changing the values of BC. We are still in the same column, but we are going across multiple rows. Whatever rows we are going across, we can eliminate them. So if you do the same thing here, for instance, right? So this will correspond. This term will correspond to A bar, B, C bar. This one will correspond to A, B, C bar. If you combine them, it's BC bar. So if you combine these two, you can just look at, oh, I have combined these two, I don't have to look at A at all. What is the term corresponding to this one? So it says B should be 1 and C should be off. So this last column corresponds to BC bar. Let us do this one more time. Let us look at this two ones which are adjacent to each other. If I group them together, this term corresponds to A bar, B, C, and this term corresponds to A bar, B, C bar. So we have that as an expression here. A bar B is common, so A bar B you can take it out, and these two ones correspond to A bar B. So from the picture, if I want to infer that, I can say that the oval is across these two ones. In these two ones, if you notice where the columns are, the column for C is changing, the column for B is remaining the same at 1, so B is remaining at 1, and this is in the row 0, we haven't moved to row 1. So row 0 which corresponds to A bar, we have A bar, so this is corresponding to A bar B. So the way I read this is, I looked at which columns it's crossing, and that variable will not appear in the product term. Wherever you see the labels are constant, so in this case the label for B is constant, it's for 1 and 1, so B is constant across these two columns, so I put B here, and it's in this row where A is corresponding to 0, so I take the logical AND of those two, so it's A bar and B. So you can as an exercise try and see what is the expression corresponding to grouping this min term and this min term, right? This min term and this min term, if you group it together, they are adjacent because I talked about this, right? You can fold, and if the paper will touch each other, so you can take the table and fold it, and the one here will touch the one here. So you go and find out what is the term corresponding to taking these two ones and combining them, and you will see that it is actually corresponding to the fact that A should be 1 and C should be 0. So you will see that the term corresponding to this is AC bar. So I don't need to do Boolean minimization like this. I can straight away tell you that the ones that are here and here will combine and give you AC bar, and the ones that are here and here will combine and give you A bar, C bar, right, because it's A